Okay, so let's say we're going to go the opposite direction. We're going to give you the zeros, and you have to figure out what the polynomial is. So let's say that I give you the zeros as 2, 1, 2 again, and negative 3i. And I want a fifth degree polynomial, meaning it should be x to the fifth at the end. So the first thing you're going to want to do is you want to recognize that first off something's missing. You need 5 zeros. We've got 1, 2, 3, 4. Also notice that we've got that negative 3i, which means we automatically need to have a positive 3i because remember the conjugates. Okay, so now we have the zeros and we need to work our way backwards. So we need to say, okay, what does it mean for x or for 2 to be a 0? What it means is that it means if we have a 2 here, it means that x minus 2 is a factor. And if we have a 1 here, that means x minus 1 is a factor. And that 2 means x minus 2 is a factor. Yes, I have it twice. You need to have it twice if it's listed here twice. Okay, then I have x plus 3i, and I have x minus 3i. And now it's our job to work this out, multiply it out, see what we get. The first and easiest thing to do, the best thing you could do, is multiply your x plus 3i and your x minus 3i. Now this of course becomes more difficult if, let's say, instead of negative 3i, it said 1 minus 3i. Then your polynomial, or your factor that you're putting together, would be x minus 1 minus 3i, and you would have to multiply through by that negative, and you'd get this 3-term thing that you would have a big box for. I'm not going to do that here. We're just going to figure it out as a 2-term here. So we've got x plus 3i and x minus 3i. So we've got x squared, 3ix, negative 3ix. And then for the complex here, we've got negative 9i squared. I squared is negative 1, so it's a positive 9. So what that means is this right here, the 3ix and the negative 3ix cancel, and we get x squared plus 9 as our bubble there. And then we still have all of these. And then we can just go ahead and keep on working our way through, multiply 2 of them out. I'm going to switch colors here. So we have x minus 2 and x minus 1. Go ahead and multiply them out. You should be really good at this by now. So we have x squared minus 3x plus 2. I'm going to go ahead and multiply these two out now. We have x minus 2, x squared plus 9. So we've got x cubed minus 2x squared, 9x, and then a minus 18. So I put x cubed minus 2x squared plus 9x minus 18. You see this is getting kind of big now. Now my next box that I'm going to make is going to have to be a 3 by 4, which is a pretty massive one. But we can do it. It's really not any more difficult. It's just a little bit more work. So we've got x squared minus 3x plus 2. Up here we've got x cubed minus 2x squared plus 9x minus 18. Go ahead and switch colors. Let's go to white here. So what do we got? X to the 5th. We've got minus 2x to the 4th. We've got 9x cubed and minus 18x squared. And we got minus 3x to the 4th, 6x cubed, negative 27x squared. I didn't give myself much room. You might want to give yourself more room. And let's see. What is that even? 3 times 8 is 24. Okay, 54x. And then we've got 2x cubed minus 4x squared, 18x minus 36. Okay, and then my answers is all those put together. So let's see here. I've got x to the 5th. I'm going to write over here. For x to the 4th, I've got minus 5x to the 4th. Everything's kind of a diagonal. It works out really nicely for us here. What do we got? 7, 16x cubed. And then for the negatives, we got some massive negatives here. We got 30, 45, negative 49x squared. For the x's, we've got 60, 72 plus 72x minus 36. So it got pretty massive, but you know what? It's really doable. The box makes it really doable. And so that's how you take zeros into a polynomial.